So in this section, we're going to be talking about linear functions and their models. And this is going to be a very easy section. It's not really much to do. It's just a matter of just reviewing, and then we're going to just do one or two examples of just a linear function and a model that's actually predicting some sort of situation. So first, recall. All right. A linear function has the form f of x equals ax plus b. And the key to this, all right, is that the x variable is raised to the first power. So that's what makes this whole function here linear. Now, another very interesting feature about a linear function is the fact that the slope is always constant. All right, and we could verify that just by looking at a graph of a linear equation, or in this case, a linear function, and notice that no matter what you do, it's always going to be rise over run to get to your next point, and then rise over run to get to your next point, and rise over run to get to your next point. And this is constantly going to be the same exact thing. So that's what makes linear functions extremely important, because we can easily identify future predictions and stuff like that. In fact, some of you in the room may be going on for higher mathematics, like like trig, Calc 1, Calc 2, Calc 3, Calc whatever, really, differential equations. And there's one class that you're going to be taking, which is called linear algebra, which is just the study of lines and spaces and vector spaces and all this other interesting things that we can do with lines. Now, I do want to go over, like I said, just a very simple example here. And I really want to illustrate what the linear function looks like, and then how do we actually interpret the slope? Because interpreting the slope is so much more than just calculating it and telling me what number it is. Okay, so here's our problem right here. And it just basically reads, a dam is built on a river to create a reservoir, and the water level, f of t, in the reservoir at any time t is given by the function f of t equals 4.5t plus 28, where t is the number of years since the dam was constructed, and f of t is measured in feet. Now, before we answer any questions here, I want us to really understand, what functions actually do for us. So remember, you're going to have some set of numbers, and we're going to call this our domain, okay? Now, this will be all of the t values that you're allowed to use for this function. And then you have another set of numbers, which we call the range. All right, and this is going to be f of t. In other words, the t values are your input values, or another way to say this would be your independent variable. And then f of t will be your output. And another way to say that is your dependent variable. So, for example, you can have some number, let's call it t1, and that is going to map over here into our range, okay? And now, excuse me, how do we get that? Well, we just take 4.5, multiply it times t1, and then add 28 to it. We can also have another t value called t2. Well, this will just be f of t2. And like I said, what this does is it allows us to predict things. So maybe in the year 2057, we could figure out what is the water level in the year 2057. Okay, so that's what functions do. Okay, now the first thing we're gonna do here is part A. We're just gonna sketch a graph of f. Now, I'm a huge fan of Desmos. I'm a terrible artist, so I'm not going to pretend that I'm really good at this, or I'm not going to pretend I'm going to draw this. So I'm just going to go ahead and graph this and just copy and paste it into our notes. All right, so here's our graph. Looking pretty good. Nice constant slope here that we have, okay? And that's going to be part B. Part B is just going to be, I'm going to write it off to the right here. we're just going to label M, which is our slope, which is going to be 4.5, okay? But now, here's how we interpret this slope, okay? So this is going to be part C. Boy, spelling is hard for me tonight. All right, so here's how we interpret this slope. First thing we got to remember. Slope is, and I know a lot of us want to think it's rise over run, but I'm begging you to get that out of your daily vocabulary. You want to think of slope as change in y over change in x. And the reason for that is because slope can be positive or negative. And if you think it's rise over run, then you're always going to be thinking it's increasing when in fact slope can be decreasing. So please think of this as change in y over change in x. Now, our slope happened to be, and I'm going to write it on the very bottom here. Our slope is 4.5 over 1, which means this is going to be our change in. Now, we know technically it's y, but in this situation, we're not using the variable y, we're using f of t, okay? And then this down here will be our change in t. But what I'm going to do is I'm going to take this even one step further, okay? I'm going to erase the f of t and the t because I want to actually write out words. I think words are so important, and we don't use words enough in mathematics. So the 4.5 represents the change in water level, and the 1 represents the change in time. And now that we have an actual definition of what these variables stand for, we can interpret our slope as, for each 1 year in time, the water level will increase by 4.5 feet. So that's one way that you can interpret this. You could also you can write it with the y or the water level first and then time second. So I'll do that too. So for each 4.5 feet increase, time will increase by 1 year. And to be honest with you, it's really any way that you can write this to make it like make sense to you or make sense to your reader. It's just you want to make sure you include the keyword increase, okay? You want to make sure you include this word increase. And that's because our slope is a positive number. All right? If it was negative, then we would say something like decrease or getting smaller, something of that nature. Okay? So that's basically it for this video. Very short video because, like I said, we already have an idea of what functions are and we know what linear functions are. The key to this was just to learn how to interpret slope as a rate of change. And that is what I really want you to get into your daily vernacular, which is slope is the change in y over the change in x. All right, so please get rid of that rise over run business because it doesn't help anybody. So on that note, I'll see you in the next video.